Okay. Hey. Hey, Abby. What's up, Caitlin? All right, let me do a quick check of Summit to see if I need to approve any focus areas, and then we'll go calculus, college algebra, math analysis. Okay. Cool. So let's go ahead and go for it. Okay. All right. We talked last time about, well, we finished up talking about parabolas and hyperbolas, at least the introduction to. Okay. But again, if you want to pass the AFA, it'll take some more studying on your own, some more practice. However, if you have questions about it, then feel free to email me or feel free to ask me. I can come into the stream during office hours, or if you want to do like a Zoom conference or something to work on that, let me know. But otherwise, we're going to move on. But first, let's go ahead and do our warm-up. Okay. Whoa, I can't get my... Come on, there we go. All right. Okay, put the general form into standard form and classify the conic section. So, general form to standard form, hopefully we're feeling more and more comfortable with. So it always starts off by taking the constant, moving it to the right, and then let's group x stuff and group y stuff. So negative 4x squared plus 16x plus 9y squared plus 18y equals 43. Now, normally we would just start completing the square now, but both of these square terms have a coefficient on them. So before I complete the square, then I need to factor out each of those coefficients for each group. So for the x's, I'll factor out minus 4. So that turns into x squared minus 4x. Now I'll leave some space for my completing the square. For the y stuff, I'll factor out that 9. So y squared plus 2y. I'll leave some space. Equals 43. b over 2 squared, negative 4 over 2 is negative 2. Negative 2 squared is 4. So on the right side, that's sort of a plus sign. On the right side, I don't want to just add 4. I'm adding negative 4 times 4 because there's this negative in. Okay. Don't forget this step. It's such a crucial step that will ruin everything if you don't. If you just add 4 on the right side, it's going to be so screwed up. So we have to remember, if we factored out something, multiply that with whatever we add in to complete the square whenever we add on the right side. 2 over 2 is 1. 1 squared is 1, so plus 1. So we're multiplying 9 times 1 on the right side. So on the right, what do we got? 43 plus negative 16, so minus 16, plus 9. 36. And then on the left, so negative 4, this would turn into x minus 2 squared plus 9, y plus 1 squared. And then lastly, I just want this to be 1 on the right side instead of 36. So I go through and divide everything by 36. Gives me the 1 on the right side. Now I need to simplify fractions. 9 over 36 would simplify into 1 over 4. Negative 4 over 36 would simplify into negative 1 over 9. Okay, and then just one last thing is, again, we always want the minus sign to be in the middle, so I'm just going to flip these terms around so that they're written like that. So I'm going to put the y plus 1 squared first over 4 minus, we like the minus to be in the middle if there is one. Okay, so there's my standard form. And then it says classify the conic section so determine what kind of conic it is. So from there, if there's the minus sign in the middle, this almost looks like the equation of an ellipse, but it's a minus sign between, so that means this is a hyperbola. Right, this is the standard form for a hyperbola. We actually could tell just in this very first step, since there's this minus sign here in one of these first two that's on the squareds, I know that'll end up making one of my final pieces negative. So if I just saw that it was negative 4 or just negative 9 up here, I would know immediately, actually this should be a hyperbola because there's squareds for both. Okay. All right, so we're going to go on into systems of equations, okay, one of our last units. And this will be, luckily you've already talked about systems of equations like dating back to Algebra 1, right? Like Algebra 1A. So here's what that looks like in Algebra 1A. Here's a quick little recap. So systems of equations. So there's two different ways of solving systems of equations, or two main methods. One of which is called substitution. This is where you isolate a variable, substitute it into the other equation. So here's an example of what that looks like. Substitution is really good for when I look at my system and I see that one of the variables just has a coefficient that is 1. Right? In this case, the y has a coefficient of negative 1. But that means it's really easy to isolate. So I rearrange this equation into y equals 4x minus 20. And then y equals 4x minus 20. So the 4x minus 20 then we substitute in for the y in the second equation, right, which gives us this. We distribute, combine like terms, solve for x, we get x equals 3. Once we get x equals 3, we can plug that back into our original equation to get the y value. All right, so that's substitution. Substitution is solve for one of the variables, plug it into the other equation. And then the other kind of more common / popular one is elimination. Okay, solving by elimination. So for elimination, we multiply one or both of the equations by some constant factor to get the same coefficient but different signs on the same variable. So this is a very key piece that will we'll use today in our new methods as well. And then we add the equations together, which will eliminate. Okay, so for example, this was originally my system. And then I started looking at the -2 and the -3, and I thought, wow, it would really be easy to get those to be 6 and -6. So -2 times 3 gives me -6 here. -2 times -3 would give me the +6. So again, that's what we want, is the same coefficient, but one positive, one negative. Right? But we multiply the entire equation by that thing. Add the equations together. It eliminates the variable y, so now there's only an x, and we just solve for x. Once we know what x is, then we can just take x equals 1, plug it into the equation, to one of the equations from before, it doesn't matter which one, and then go through and solve for y. Oops. Oh no. Oh no. I can't stop it. Ah, I fixed it. I'm so smart. So elimination, substitution. Most popular methods. So let's take that, and those are obviously too easy. You guys have been doing those forever. So let's solve a system of equations in 3 variables. So not just x and y. Let's make it like x, y, z. All right, so much more fun. So here's the process we'll do. We're going to pick any 2 equations, and we'll eliminate a variable just through normal elimination. We'll pick 2 different equations, but we'll eliminate the same variable from our previous step. So we're like either always eliminating x, or always eliminating y, or always eliminating z, whatever. So now we have a new system that is just 2 equations, and we'll just solve that like normal. Okay, you guys know how to solve, or you have solved a system of 2 equations, 2 variables, right? That's going back to that stuff I just talked about, like the Algebra 1A stuff. Okay, and then did it in 1B, and probably in Algebra 2, right? Maybe, I don't know. But it's something you've done, I know that. The hardest part in this stuff is just keeping track of stuff, right? It's easy to lose track of what equations you're using. It's easy to lose track of like a single negative sign. There's just lots of tiny calculations in these problems, so even one mess up of those, one slip, one forgetting to write a plus sign or something can screw up everything. All right, so just double check your work at every step, because even I screw these up sometimes whenever I'm just, start going too fast and miss a negative or something. So we'll see if I mess up here. Hopefully not, but it is me, so we're here. Okay, so the first thing I need to do is make a decision about what variable do I want to eliminate. Can I show the steps again? Yes, sir. Pick 2 equations, eliminate. Pick 2 others, eliminate again. We now have a system. Solve the system, like normal, using regular elimination, substitution, like we've done before. Good. Hey, let me know when you're good. I'm just gonna drink my tea here. Cool. All right, let's do it. Oh no. Okay, so first things first, let's decide which variable to eliminate, x, y, or z. Well, hold on a second. Look at my second equation. My second equation doesn't even have a z in it, right? Just x and y. These other ones have x, y, z, but this one's just x, y. So that's awesome. That means the part of this work is already done for me. This is like step 1 done for me. So I'm going to do something, you'll see me do this a lot, where I put like little stars, asterisks. Whew, that's tough. Next to an equation, and what these little stars tell me is I'm going to use this equation later. All right, like I said, it's easy to lose track of things, so wherever I like star something, if you circle it or you want to put some sort of symbol by it or something, I'd recommend doing it so that you can keep track of what you're using. Okay, so I don't even have to do step 1. Step 1 already eliminated z for me. Wow, amazing. Okay, so let's go to step 2. We'll pick 2 of the other equations and let's eliminate the same variable. So I'm going to look at the first equation and third equation, and I also want to get rid of z since the second equation already has z gone. All right, so let's get rid of z, stay consistent. Okay, so as I look at my coefficients for z, I have -2 and -1. Remember, my goal is that I have them the same thing, right? Where one of them is positive and one of them is negative, but they're the same number. So right now I have -2 and -1. So let's change this one so that it's +2. Oh, that's not what I want. What just happened here? Oh, it's calligraphy pen. I don't want the calligraphy pen. Okay. So we're going to multiply this by -2. And so that has to get distributed to everything. So -2 times -4x, 8x. -2 times y, -2y. -2 times -z, plus 2z. -2 times 12, -24. This first equation, I don't need to do anything with it. Sometimes we might have to do something to both, but in this case we don't. So I'm just going to leave this as is. I'm just going to copy it down exactly how it was. X minus y minus 2z equals -6. And now this has exactly what I want. The -2 and the +2, right? Same number but different sign. And let's add these together. X plus 8x, 9x. -y plus -2y, -3y. -2z plus 2z, 0. -6 plus -24, -30. And again, I'm going to put some asterisks here that tell me this is an important equation. I'm going to need it again in a second. Right. But as we can see by those equations, we have 2 new equations that don't have z in it. So let me copy down those equations again just over here. So these are those same pink ones that I starred earlier. 3x plus 2y equals -25. 9x minus 3y equals -30. And now this is just like, this is basically exactly like one of those first equations that I showed you, right? Like the substitution or elimination, where we just had 2 equations, xy, xy. Okay, that's exactly what we have here. I have 2 equations. There's an x and a y, and an x and a y. So we just have to solve them by elimination or substitution. All of these variables have coefficients that are not 1, so I probably don't want to do substitution. I could, but let's instead practice using elimination. So we can eliminate x or eliminate y. It's up to you. It doesn't matter which one. Usually there is an easier choice. So in this case, my easier choice would be to eliminate x. So I'm going to multiply this first equation by -3. That gives me -9x minus 6y equals 75. This bottom equation I'm going to leave as is. So notice I have positive and negative 9 on the x. If you had wanted to eliminate the y's, you totally could. You would have just had to multiply both equations by something. So like we would have had to multiply the first equation by 3 and the second equation by 2 so that we would have positive and negative 6. But that's more work. You're multiplying another equation where we don't have to, since if we just multiply this first equation by negative 3, we already get the negative 9, positive 9. So, but you can do either way. Some people really like one way or the other. Let's add. So that's 0, negative 6y plus negative 3y, negative 9y, 75 plus negative 30, 45. Divide both sides by negative 9. Y equals negative 5. So there's a good start. And it's not my final answer. That is just the y value. All right, but we have 3 variables, x, y, z. So we're trying to find all 3 of them. So far we found y, which is a good start. Okay, so now let's go back and figure out x. Let's use one of these. Yes, negative 5. Thank you. I think I had it and then erased it. Let's use one of these pink equations, doesn't matter which one, to now solve for x. I'll just use this first one. So 3x plus 2 times y, but y we know is negative 5, equals negative 25. So 3x minus 10 equals negative 25. Add 10 to both sides, so 3x equals negative 15. Divide both sides by 3. X equals negative 5, so also negative 5. Okay, it's fun. And then lastly, we just have to solve for z. So now we go back to one of our original equations. We can choose to now solve for z. Well, we definitely wouldn't want to choose the second one because the second one doesn't even have z in it. So choose either the first or the second. It doesn't matter which. Let's use, or sorry, the first or the third. Let's use the third, just because. Negative 4x, but x is negative 5, plus y plus negative 5. Minus z equals 12. Negative 4 times negative 5 is 20. Plus negative 5, so minus 5 is 12. Right, now it's just solving. 20 minus 5 is 15. Subtract 12 from both sides. 15 minus 12 is 3. Add z to both sides. I get 3 equals z. And the way that we'll actually write this final answer is, if we just had x, y, we would write a pair, an ordered pair. So we'll do that same thing, but instead of just x, y, we'll write x, y, z. So negative 5, negative 5, 3. There's my final answer. Please do make sure you write your final answers in this form, where it's x, comma, y, comma, z. This is also the form that you'll have to enter it in on the PFA. Okay, so you'll have to type this in on the PFA. It's not multiple choice. So you'll do parentheses, number, comma, number, comma, number, parentheses. Don't put any spaces anywhere. Right? If you put a space, it'll definitely not be right. Okay, so just put it all together. Never touch the space bar. Number, comma, number, number, comma, number, comma, number. Neat. Okay, so let's just practice one more. Okay, so 3 equations, 3 variables. We have to first make a decision of which variable do we want to get rid of. Now you can choose either one, just sometimes there's easier choices than others. Okay, but looking at the x coefficients, looking at the y coefficients, and the x coefficients again, or sorry, the z coefficients, probably the x's would be easiest. -1 and -1 are easy to work with because if we multiply any number by 1, it's just itself. So let's probably start by eliminating the x's. And let's first deal with these 2 equations. All right, so this first one, I'm going to multiply by -1 though. So that would give me positive x plus 5y minus 6z equals positive 24. This third equation, I'll just leave it as is, negative x minus 4y plus 5z equals negative 21. And then we'll add those 2 equations together. Column by column, just moving across. So 0. 5y plus negative 4y is just y. Negative 6z plus 5z minus z. 24 plus negative 21, 3. And I'm going to star this equation so that I keep track of it and remember that I need it for later. Okay, so now I want to pick a different 2 equations. All right, and eliminate x again. Since we eliminated x the first time, we want to eliminate x again, but with different equations. So I'm going to also number these. So equation 1, equation 2, equation 3, just so I can easier write those. I'm going to choose the first equation and the third equation. And the first equation I'm just going to leave as is. 5x minus 4y plus 2z equals 21. But the third equation, so to eliminate x, I'm going to need that third equation to have a negative 5x, since this has positive 5x. So what do I need to do to that third equation? I need to multiply it by 5. It already has the negative sign, so now I just need to make it negative 5. So I'm going to multiply that whole thing by 5. That would give me negative 5x. Negative 5 times negative 4 plus 20y. Negative 5 times 5 minus 25. Or wait a minute, no, not, sorry. I screwed this up. I'm not multiplying by negative 5. I'm just multiplying by regular 5. So minus 20y plus 25z. Negative 21 times 5, negative 105. Now add the equations together. 5x minus 5x, 0. Negative 4y plus negative 20y, negative 24y. 2z plus 25z plus 27z. 21 minus 105. I don't trust myself to do these things in my head because I've been really screwing up today, my mental math. I've lost confidence. Negative 84. And again, I'm going to star up this equation because I know it's important. That's what I need to use. So I'll take both my starred equations and I'm just going to copy them down again. So my first one was y minus z equals 3. And my second one, a bit more complicated. It's this one. But this is just a system of two equations with two variables. So we're going to solve these like we normally would. So it's really just kind of a repeating processes over and over again. Even when we have the three variables, the x, y, and z, we're still doing elimination to add equations together to get things to cancel. So we're just doing it, but with more variables. So now we're down to a 2x2 system, two equations, two variables. We can choose which ones we want to eliminate. I mean, looking at my coefficients, I don't have one particularly easier choice than the other. I'll just choose y. I don't see why not. So I'm going to multiply this first equation by 24 since I need it to match with the negative 24. So 24y minus 24z equals 84. No, not 84. Told you my mental math. Right, 20 times 3 would be 60, 4 times 3 would be 12, 72. I don't know what I'm thinking. I've been off today. Okay, the second equation I can keep the same. And I'll add them together. 0 for the first column. Negative 24 plus 27. 3z equals negative 12. Divide by 3. Z equals negative 4. So that's 1/3 of my answer, right? Because I need x and y and z. But now that I know z, let's go back to one of these green equations, and probably this first one, because that's much more simpler, much smaller numbers. So y minus z, y minus negative 4 equals 3. So y plus 4 equals 3. Gives me y equals negative 1. And then lastly, let's go back to the very beginning. We know y and z now, so let's go back to one of our original equations and plug in y and z so that we can solve for x. It doesn't matter which one you choose. If there's an easier one, you can go for that one. You don't have to. I don't know. Let's say I'm going to have to scroll up and down a lot because I can never remember these. Negative x. Let's do the second one. Negative x minus 5y. Okay. Negative x minus 5y. So that'd be negative 1. 5 times negative 1. Plus 6z equals negative 24. So plus 6 times negative 4 equals negative 24. Is that right? Minus 5y plus 6z equals negative 24. Okay. I think that's good. Negative 5 times negative 1 plus 5. 6 times negative 24 minus 24 equals minus 24. I could combine the 5 minus 24 here, but I'm looking here, I see, look, minus 24 on both sides. So if I added 24 to both sides, it would automatically just get rid of those, leaving me with 0 on the right. Then I'll add x to both sides. So I get 5 equals x. So my final answer, 5, negative 1, negative 4. These aren't the hardest problems in the world, they're just annoying. And it's, even if you understand it completely and you know what's going on, it's still so easy to just mess up a negative. Right? Even like I did up here on that last one, or was it on this one? But I had originally, where'd it go? Yeah, it was on this one, where I had originally written y equals negative 5, and then I erased my answer just so I could rewrite it again, make it look nicer, and I forgot the negative. Right? It's just a single, half a second lapse in judgment or remembering something, and if I would have kept going, if I didn't have you guys here, it would have screwed me up. I would have gotten some messed up numbers here, and then I would have had to go back and fix it and find out where I went wrong. All right? It's so hard to look back through all this work for the one thing that you did wrong first. So double, triple check yourself at each step. It's annoying, but you'll save yourself some time in the long run, because then you won't have to go back and start from scratch if you mess up, because you won't mess up. Okay. We'll talk about these tomorrow. This is a different situation of what can happen. We'll still go about it the same way, but we'll end up with something weird that we have to consider. But here's how we would actually just kind of do a normal solving. So what this point represents is, where do these three lines intersect? All right, now, since there's three variables, so this gets a little weird. I won't go too in depth here. But what this represents is a three-dimensional graph. Okay, so instead of just normal XY plane, if you think of looking at the XY plane, and then there's also an axis coming straight out at you and straight into the screen, all right, which is kind of what you can't see that, sorry, which is kind of what I've sketched here. All right, so these are lines that are in three-dimensional space, but all of these lines intersect at this point. Right, 5, negative 1, negative 4. All right, so that's what we're doing when we solve these systems, or when we solve any equations like this, this. We're finding where they're the same, so where do they meet? Where do they intersect? Okay, so that's all I got for today. I sent you some practice. I think, didn't I? I know I meant to. Did I actually? It's hard to say. But I'd like to think so. Yeah, so that first page is just basic basic substitution and elimination. So If you feel good about those first four, again, that's Algebra 1A stuff. But if you want to use it at least just to practice, that's fine. But the 3 variable systems, 5, 6, 7, 8, okay, those will be the good practice of going through what this is like doing these 3 variable systems. Okay. Now there is one example on there of this type that we haven't talked about yet, where something different could happen. But if you wanted to try like the first 2 at least, you could do those, or not. You can save it for tomorrow because it'll be the same assignment for tomorrow. How's the tea? It's good. We got let's see here. Let me get my sponsorship going. Hold on. Let me figure it out. Okay. We got that Lipton green tea decaffeinated honey lemon. Right, and that wasn't enough, so I actually put some honey into it as well. It's good. It's good. So go to lipton.com/abundusdoesmath, enter the promo code, and you'll get 77% off your next 77 orders. It's a pretty good deal. So big shout out to the partnership with Lipton. All right. You guys have a good weekend? Anything exciting happen? Probably not. Probably just sat inside in the cold. Freaking cold, man. So mad that it was so cold last week and this weekend. I guess yesterday was pretty decent. I'm gonna have to go to the grocery store again today. I'm kind of sad. All right, cool. Good talks. Good talks. Always love interacting with you guys. Appreciate the in-depth conversation. So I'll go ahead and log off. Do a couple of those practices if you want on that assignment I sent you. Keep requesting PFAs. You guys are doing pretty good about it. People keep kind of asking me. So again, I'm clearly not requesting that you send me notes or that you're on Zoom or anything. Okay, your PFAs are open notes at this point, right? Like it's like a homework assignment. Okay, now I recommend trying to do things without, the use of your notes and stuff. But if you're taking your PFA and you're like not sure about something, great. Use your notes. I mean, I'm not tracking you. Okay. So, get those done. And I will see you guys back here tomorrow. Hope you have a great rest of your Wednesday. Or not Wednesday. Okay, I'm done. Monday. Have a great rest of your Monday. I think it's warming up. So, get outside, take a nice walk. Go outside, skip around, blow some bubbles, things like that. Pick dandelions. That's what I'm going to do. So, see ya.